Hello everyone. Today is the 72nd day of Leetcode 75 challenge. Let's begin with the 72nd question. Question 435, non-overlapping intervals, and the level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given an array of intervals where each interval is represented as start, comma, end. Okay, so basically a list is given to us which has a representation of another array within it, and where we have a start value and an end value. And now you are tasked to remove the minimum number of intervals so that the rest of the intervals do not overlap. So there might be a scenario that the intervals might be overlapping, and we have to remove the minimum number of intervals from this array. Minimum number of, not the maximum or all the overlapping, minimum number of, so that they do not overlap anymore. The result should be a single integer representing the minimum removals required. So basically, we have to return the number of count of how many we have removed, and we don't have to actually remove anything. Okay, if the intervals are already non-overlapping, the answer will be 0. Right? If some interval is given something like that which is not overlapping, okay, so the output will be 0 because there is no overlapping in that. Right? In this case, you can see. So you may assume that the input array is non-empty and each interval has start less than end. Okay, because the interval given cannot have like end is greater than start, right? That's not possible. Note that intervals which only touch at the point are non-overlapping. For example, 1 comma 2 and 2 comma 3 are non-overlapping. What are they trying to say? That if the interval is this way, this is the interval given to us, and if you draw the line, it's 1 to 2 and from 2 to 3, right? So this part, if something like this happens, then it's in this in general way, it's an overlapping situation. But in this question, it has been said by writing a note that please uh, do not take this as an overlapping sequence. It will be considered as a non-overlapping sequence. Okay, so I hope you understood the problem explanation. Now let's look at the constraints. The intervals array length would be from 1 to 10 to the power 5 and intervals of I, like basically. So so this will be the array of size 1 to 10 to the power 5, and the sub arrays within it, or the sequences within it, will have size of 2. Okay, this is what it said here. And start I and end I value within this, would be from negative 10 to the power 5 into 10 to the power 4 to positive 5 into 10 to the power 4. Okay, so I hope you understood the problem explanation and the constraints. Now let's move to the next slide. Now let's understand the input output explanation. Now let's look at the first example here, intervals, right? So what is given to us? 1 comma 2, right? So let's make a number line here. 1 2 1 comma 2. Great. Another is from 2 comma 3. After that there is 3 comma 4, and there is 1 comma 3. So let's draw it from here to here. Okay, so from here we can see that we can remove these two you could say intervals, right? So if we remove these two intervals, the count will be 2, so output will be 2, right? And why we are not removing 1 3 and 3 4? Because as the question says, if the subsequence or the interval is given this way, this will be considered as non-overlapping. That is why this has been ignored. Okay, but output we can see here, it is 1. Okay, so what mistake we are doing, or what inefficiently we are calculating here? If you can see, if you try to remove 1 comma 3 from here, suppose if we remove the 1 comma 3 from here, okay, what we are left with? We are left with 1 comma 2, 2 comma 3. Are those overlapping? No, right? 3 comma 4, are those overlapping? No, right? So we got the by removing only 1 comma 3, we got the output as 1. So this is the minimum number of overlapping subsequence which has to be removed. Okay, now let's look at the example 2. What is given to us? It's given 1 comma 2, right? 1 comma 2. Then again it's given 1, from 1 to 2 it's given 2 times. Fine. Then it's given us 1 comma 2 again. Fine. Now if you can see, are this overlapping? You might be saying no, because as we earlier knew that if something is similar, it should not be overlapping, right? But here we don't have that case. Here what we are having? We are having 1 comma 2, not 2 comma 3. Neither it is 0 comma 1, right? It's 1 comma 2, 1 comma 2, and 1 comma 2. So to remove this overlapping subsequence, what we will be doing? We will be removing this one. Again, one more overlapping subsequence is there, this pair of 1. Again we will remove this, right? So we are left with 1 comma 2 only. Suppose this is only left. right? So there are no more overlapping subsequences. So output becomes true because we have removed this one and this one. Okay. I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Now let's do that by understanding the goal. Okay. So we are given a list of intervals, each represented as start, comma, end. And our task is to remove the minimum number of intervals so that the remaining ones are non-overlapping. Right? We have the understanding of this, right? So we have to remove the minimum number of overlapping subsequences. Now, intervals only touch at a point. They are not overlapping. That means, as we saw earlier also, 1 comma 2 is there and 2 comma 3 is there. In this particular problem, this scenario is not taken as an overlapping case. Okay. The goal is to return the minimum number of removals required. And so for let's look at the efficient solution for this problem, right? There is no brute force for this problem as per my understanding, right? Or there might be, you could have the run on that. Okay. Now let's visualize the process. Now let's take an example of, let's take this example. Okay. Uh, 5 comma 10, then 1 comma 3. So first and foremost thing which I will be doing is sorting this. Now there are two ways of sorting this particular, when we get an interval type of problem. There are two ways. Either sort on the basis of start time, okay, or sort on the basis of end time. Okay, it's your way, whichever you want to do. Okay, but in this problem, I will be sorting on the basis of start. And now, why we are doing the sort, you will get to understand why. Just let me write the sorted format of it. So I have sorted this array in the on the basis of start time. If you can see, one comes first, two, three, and five, then six. Right here, you can see one was here, two was here, three was here, five was here, and six was here. Okay. Now, why I have done this? Once sorted, any overlap can only occur between consecutive intervals, making the comparison easier. What that means is that when I sort on the basis of the start time, this is one, then this is three, right? And this is two. So here you could see this time will always be less than this time, right? So if you check what is the end time of this and what is the starting time of this, if you see that okay, this time is greater than this particular time, and we know that this is the start time, that means it is overlapping, right? This makes our task very easier to identify whether the particular scene is overlapping or not. And one more scene is there. Suppose it's 1 comma 2 and then it's 2 comma 3, right? If suppose it was not sorted, right, and some values were there in between, let's suppose, now it will be a very tedious and a very hard work to find out, right? But if we sort it, what will happen? We will directly get these things, right? And we can check whether these are same or not. So this reduces our a lot of time and hard work, and sorting makes it much more easier. Okay, so that is the reason why we are sorting the problem. Now let's move on finding how we can figure out whether the particular thing is overlapping or not. So let's take a random example here. Let's take 0 comma 2. Okay, let's take this case one, 0 comma 2 and 3 comma 6. Okay, this is in sorted manner, right? Now we are checking for non-overlapping subsequence, the subsequence which does not overlap. So if you can see here, 0 2, right? 0 2, yeah, I guess you can understand this. Then there is 3 to 6. Let me write it bigger. 2. Okay, so this is the number line, or we can draw the lines like that. We can see here 0 to 2 is there, and there is no overlapping because it's a separate one. If we are trying to visualize a process, right, and it is a separate one. So what does that mean? If I say that this is current start, okay, CS, and this is current end, and this is next start and next end. So what we observed that if current end is less than or equals to I will tell you why equals to, I think you might have already figured out why, is less than next start. So it's a non-overlapping. Why? If it is less than, we have already seen. And when equal, if suppose it was not 3, it was 2, right? So it might have started from here. And this is also a non-overlapping subsequence, right? So we got our first case that, let me write it somewhere. If first condition we got, if current end is less than or greater than less than or equals to next start, it's non-overlapping. Okay, that is clear to us. Let's take another example, another case, right? Second case. Let's take this of overlapping now. So if it's suppose 0 comma 3, okay, and then it is suppose 2 comma 5, okay, and it is current start, it is current end, and it is next start, and it is next end. Okay, okay. So if I draw this line, suppose 0 to 3, and it is 2 to 5. Okay, so what you can observe here, we can observe that this part is getting overlapped, right? Very evident. Now what you have to think about is that which uh, interval should we remove, left one or right one? Now if you can see, we should try to remove only that overlapping subsequence or that interval which is greater. Let's suppose, let me take this a much bigger value here. Let's suppose it's 7. Okay, let's take it as 7. So from here, we will only try to remove that subsequence which is a bigger one. Because why bigger one? Because the one which is bigger might have possibilities that more small intervals might come into its area. Okay, there might be a case that if you go further, there is another 6, 7 in the range, right? So removing 2 comma 7 will be a great value because till 3 we don't have anything, right? But after 3 there is something that will overlap this 2 comma 7, right? And if you remove this 0 comma 3 and suppose you remove this 6 comma 7, we are removing two numbers or two intervals, right? Rather than removing this 2 comma 7. If we have removed 2 comma 7, there might be only one output, that we have removed only one overlapping subsequence. So we will always try to remove the subsequence which is a greater one. Okay, so what we figured out from here is that if the next interval, next end, if it is greater than the current end, it's an overlapping, right? And also you have observed here one more thing, that if the current end, if it is greater than the next start, right, that also serves as an overlapping sequence. Okay, so just keep this in mind. This we are doing to find out which one we have to remove. Okay, and this is also we got here, so let me write it somewhere. Let me write here, make it a star. If the current end, if it is greater than the next start, it's an overlapping. Okay, overlapping. Now this scenario here, this shows that which one we should be removing. Okay, let's take another case. Let's take this case. Suppose we are taking 0 comma 3 comma 1 comma 2. Let's take it as 4. Okay, it goes from 4 and it goes from 1 to 2. Okay, so this part is getting overlapped. Now again we got the same scenario. Now which one should we remove? Should we remove, right? Again I will say the same thing here. What's happening is that suppose it's 4, right, and it's 1 comma 2, there could be another scenario which is 2 comma 3, right? So we have to remove this 1 comma 2 and 2 comma 3 also. Instead of removing these two, what if we remove this one 0 comma 4, because it is the greatest interval, right? It is the longest interval. Removing the longest interval makes much more sense. Okay, so from here we figure out that if the current end is greater than the next end, we should remove which one? The current end, right, or the current end interval overlap. So these 2 points, point 2 comma 4, point 2 and 4, says that whenever the next end is greater than the current end, or if current end is greater than next end, please remove the greater one. Okay, greater one, remove the greater one. And this point number 3 says or identifies that if the current end is greater than the next start, okay, then it identify as a overlapping subsequence. Okay, and the first point directly says that if this kind of scenario happens, if the current end is less than or equal to the next start, it's a non-overlapping subsequence. Okay, I hope you got this. Now after understanding this part, we should also see that, let's take the point number 2 here, which was example as 0 comma 3, right, and 2 comma 5. So if I was standing here, suppose I was standing here, okay, and we compared this with this, right, with these values, and we found out that next end is greater than the current end, right, which means that we're gonna remove this one. So what will happen? And suppose this is j, okay. So what will happen? This will be done, right? This is done. So that means we will be removing this one. So if we remove this, we will increment this j ahead, okay. Now this I value will be compared with this j value, okay. And after that, suppose this scenario comes up, this ce, the current end, suppose this current end is greater than the next end. Suppose this is a scenario. Now what will happen? We have to remove this one, right? So what we will do? J, which is this one, j will be here, and I will come in place of j, okay. And after that, j will increment by 1, okay. That means that a new subsequence will be started from here. I will be standing in the j's position, and j will be incremented by 1, okay. This is what will happen, okay. So I hope you got this part also. So now let's try to understand it in much more clearer manner. So what we observed earlier, that in point number 4 and 2, that we try to exclude the maximum value range, which basically had the next end as the greater value. Suppose if it was 0 comma 3 and it was suppose 2 comma 8, right, they're overlapping. So what we were doing, we were trying to avoid this range because it is a longer range, right? So what if I do, and one more thing, yeah, let's take this first and second. This is the first case, second case, right? And let's take the fourth case. Fourth case says that it's 0 comma 8 and this is 2 comma 3 overlapping, but here we can see that 8 is greater than this end, right? So we will be removing this. What that means inversely, that we are trying to take the minimum range ahead, minimum range and value ahead, right? Here also we're trying to take the minimum value range ahead, so that we can exclude this, so that when we compare with the next uh, interval, we take this as the current end, okay, or this as the current end, and that will be the next end, okay. I hope you're getting the situation. So for that, if I do like this, minimum of current end and the next end, right, this will automatically give me this value, the 3, or this will give me this 3, depending upon whichever is the minimum, and this will exclude the maximum one, right? Makes sense? I have just joined these two conditions in one. So how this will help us is that, suppose this is the scenario, right, and this value is here, this value is here, and we are excluding this, right? So we got the minimum value from here, and then we will compare this value, right, and we already have end or the current end as this, and this will be our next end, definitely. Now if this is the same here, this way, and this is the one which we have to exclude. So this was the current end, right? So this will get the minimum value, the end will have the minimum value, basically current end, okay. And this will be compared with this value, right, because this will increment, this will get incremented. I hope this thing is clearer to you now, okay. Now let me clear this up, okay. Let's try to understand this with an example, bigger example, since we have done with the small examples. So if you can see here, we have the end, right? I have written it as 3. Why? Look, I have sorted the array already, right? The 3 is the current end, okay. This is the current end. Let me draw now number lines. So it's 1 to 3, then it's 2 to 4, then it's 3 to 5, okay, then it's 5 to 10. Let me draw it a bit much longer. 5 to 10 goes till here. Then there is suppose 6 to 8, okay. Here what we can see that this is overlapping, right? This is overlapping and this is non-overlapping, right? If we apply what we have already understood till now, we can see there in 1 comma 3, the end value, which is 3, right, is end greater than the next start, okay, next start. Because first thing is this, right, next start or not, it is. That means there is a overlapping situation, when we can see that there is definitely an overlapping situation right now, okay. So what we'll do, if you remember, we had two options. if current end was greater than next end, current end was smaller than next end, right? And to replace this, what we did, we took the minimum of both of them, right? So if we take here, current end is what, 3, which is this value 3, and what is the next end, it's 4, right? So the minimum will be 3, so my end still remains 3. Okay, that means, what that means, that means that, hey man, we have excluded this particular part. Okay, so I will move from here to here, and this end is still, now the last end is still this one. Okay, here, great. Now again we check the end which we have, and here basically, and the next start, which is this, is it greater? No, it is not, it is similar. Similar means what? It's a non-overlapping subsequence. That means that, what we will do, we will update our end to 3 again, basically this 3, right? This one 3. That means that, hey man, this particular side is done to us, now we are left with this side, we will move ahead. Okay, now at 3 we are standing, and after that the I will be here, and we have the end value with us, which is 3 again. We will compare, is the end which is 3, right? Sorry, which is 5, my bad, it won't be 3, it will be 5, it's my mistake here, because we compared the current end and the next start, but we need the current end value, right? So this will be here instead of 3. Now we are standing here, what we will do, we will check, is the this end, basically this 5, is greater than this? No, it is not, it is the same scenario again, right? So this will be get replaced, and the current end will be changed to 10 again, because this is not an overlapping subsequence. Now we have to compare these two only, right? Again we are standing here, the end is 10, right? And the next start is 6. That means it's an overlapping subsequence, and here we can see that it's definitely an overlapping subsequence, this one, right? And here we can see previously it was not overlapping, right? It's an overlapping. So what we'll do, we will take the minimum of the end, which is 10 right now, and next next end, which is 8, right? So which is the minimum? It's the 8, right? So we will be removing this 5 comma 10 from our sequence, because 5 comma 10 is greater than 6 comma 8, right, in the interval period also, right? So till now we have removed two overlapping subsequences. Okay, so I hope you got the visualization process and the intuition of this part. Okay, now let's move to the next slide. So now let's look at how we can simulate this. We will sort the intervals by the starting time. That's simple, intervals dot sort. We keep a variable n to track the ending time of the last valid interval, which is this, as we remember. And one more thing to be clear here, when I do this in the beginning, I take the end, then I start with the index 1, right? We took the values from the index 2, 0, right? Now this basically means that till now, the end which we have got is this, suppose x, okay? And all the other values which we got are getting overlapped, and they are greater in range. So we're considering this. So the next value which we will get will be compared by this value. Okay, so this is what it means. We iterate through each interval. If the current interval start is less than the end, that is the overlapping subsequence. It's 2 and it's 3 and it's 4 and it's 6. So it's an overlapping subsequence. No, it's not an overlapping subsequence. It's supposed to be greater, it's supposed to be 8, and it's supposed to be 3. Now it's an overlapping subsequence, right? So what we wrote here, if the interval start is smaller, this one is smaller than the end, it's an overlapping subsequence. So what we do, we increase the count, we take the minimum, and we move ahead. And now we know why we take this minimum and store it in the end. And otherwise, if it's not an overlapping subsequence, we just update the end with the current end. Suppose if this is 1 comma 3 and 3 comma 6 is not an overlapping subsequence, right? So what will happen is that this is done, right? We were taking this as the current, so this will become our new current, and we will move ahead. So this is what it's done here, and we maintain a count to record how many intervals has been removed, count 0, which we increment here, and at the end we return the count. Okay, what we figured out? We figured out that sorting ensures you always check overlaps in correct order. The greedy choice of removing the interval from the larger and minimizes future overlaps. We only traverse the list once after sorting, making the solution efficient. Okay, so I hope you understood the intuition explanation. I know it was a bit tricky one. I would like you to rewatch the intuition part again if you have any doubts. So let's move to the next slide now. Now, since we got the intuition of the problem, let's look into the approach how we're gonna solve it. So step one is sorting the intervals, for which what we do, we use interval dot sort function to sort the intervals, because after sorting, checking overlaps reduces to comparing each interval with the previous one. Now step two is initialize the tracking. Track the end of the last kept interval and removal counter. So we take this count 0 and end. Why? End helps to detect overlap and count records the removal. I hope you remember this what's doing. Now step 3, single pass to resolve the overlaps. So what is there is the current start. Okay, the current start, if it is less than the end value which we have stored earlier, if you remember, if it is smaller, then it definitely means overlap. That means that if it's 1 comma 4, right, and 4 is our end value, and currently we are having 3 comma 6, so it's definitely overlapping, right? Because 1 to 4 is this, and from 3 to 6 is this, right? This part is overlapped. Okay, this is what is written here. Then we do this. Okay, keeping the smaller and leaves more room for future intervals. Classic greedy choice. It's a greedy solution because here we are trying to take the minimum only, right? We are trying to avoid the maximum interval part. It's a greedy solution. Now, finally, after doing everything, we return how many intervals were removed by returning the count. Because each time we increase the count whenever we find a overlapping subsequence. Okay. So I hope you understood the approach explanation. I know it was pretty straightforward and small. So let's move to the next slide now. The code is the exact copy of the approach discussed. Let's understand it line by line. So if you remember the approach, I already have written the code there itself. So let's recall the code here again. We sort the interval by the starting time. We take the count to count the overlapping subsequence and to store the current end value from where we will be starting. Okay. Then we will start our range from index 1 rather than index 0, because index 0 value already we have stored here in the end. And we don't, and now from index 1, we will be comparing this index 0. Okay. That is why we start from index 1. And if this condition is true, we increase the count, we take the minimum, we give the smaller end. Otherwise, there is no overlapping, then we update the current end. Right? Suppose it was standing here, and from here it's not overlapping with this value, okay? This starting value. So these are done. That means so this will come and this will become the new end. Fine. And after doing all of this, the total we will return the count. Now the time complexity for this problem will be n log n. Why n log n? Sorting takes n log n time complexity. Okay. And you will say that we have the for loop also. Yeah, we have the for loop. It's like n log n plus n, the size of the array. But since this n log n is greater than n and it's an addition value, so we will be considering only n log n. Okay. Otherwise, it is n log n plus n. Okay. And space complexity is O of 1 because we are not using any data structure to store our solution. We are just using a constant variable to store the counts. So I hope you understood the code explanation. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. So let's take this example here. How it is? It is 1 comma 2, then it's 2 comma 3, and it's 3 comma 4, and it's 1 comma 3. Okay. If we sort the interval, what will happen? Let's sort it then. It will become 1 comma 2, 1 comma 3, 2 comma 3, and 3 comma 4. Okay, this is a sorted interval. Fine. Now count is 0. Let me store count here. End value is what? Now end value will become from here 0th index, first index value from 0. This is 0 1 2 3, right? So when we do intervals of 0, we are at this, and when we do 0 intervals of 0, then 1, that means we are taking this value. Okay, so it's 2 here. Now we do the iteration from first index, so basically we're starting the iteration from here. Okay, now we check if the intervals of I0, which means that I is this, it's standing here, I0 means this, right? So if 1 is less than 2, and yeah, it is, right? So what will happen? Since it is true, our current end will change. Okay, since it is true, that means that there is an overlapping 1 comma 2 and then 1 comma 3. There is an overlap, right? So we'll increase the count to 1 and we'll take the minimum of both of them of this and 3 and 2. What is the minimum of 2 and 3? It's 2, right? So 2 so and value won't be changing, and we will move ahead and we will come here. Fine. Again we will check for the values here. Intervals of I 0. It's 2, right? Is it less than the end? No, it is not, because they are not overlapping. If you see 1 to 2, then 2 to 3, right? This is a non-overlapping subsequence. So what will happen? Our end will change. Our end value will become now intervals of I1, which is 3. Okay, great. Now I will get incremented and will come here again. And now we are standing at the last value. This one. Here is 3 less than end, which is 3 again. It is not, because 2 to 3, 3 to 4. Look, there is no overlapping. So again, what will happen? This condition will become false and will come here, and end value will change to 4. Okay, and I will come out of the list or loop. Fine. So the count value remains 1 and we return count, which is 1. Okay. So I hope you understood a dry run. And if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach and the code. And after that, do a dry run by yourself on 2-3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now since you're familiar with the problem and the solution, let's move to the lead code and code the solution. Okay, let's start by sorting the intervals first. Intervals dot sort. Okay, then we will have count equals to 0 and equals to intervals of 0 1. Okay, and this can also be written as previous end. I hope this makes sense now. After that, for I in range starts from 1, goes till length of the intervals, I will get the current start value, which is intervals I 0. Then we'll compare if current start, if it is less than the previous end, that means there is an overlapping, so we'll increase the count. Then we'll update the previous end value, minimum of, and here also we can do one more thing. Here we can get as current end equals to intervals of I1. So this will give the current end, right? So current end comma previous end. Okay, this will give me the uh, interval which is longer one, so we will exclude that one and take the minimum one. Else previous end will be the current end, non overlapping, and I will return the count. Now let's try submitting for the sample test cases. Now let's finally submit the solution. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.